All right, today is called condensing and expanding logs. It's not just condensing, it's also got some expanding on it. So condense and expand logs. So let's make sure you understand what I'm even talking about. This is just a log. And if I wanted to, I could put a number in front of it. Now, you've never seen one like that, but you can times the whole thing by 4. All right. And then if I wanted to, I could have another log that I add to it. It's like, also, they'll need to be the same base, and this is the key to one of your homework questions. If they don't have the same base, you just can't condense them into one log. You just can't do it. You just got to say, I cannot condense them. All right, so if let's say that there was a 5 here, and let's say I put a 7 there. No, that's too big. Nobody can do that in their head, so I'm going to put a 2 here. There we go. Okay, that is a typical big log problem that needs to be condensed down to one log. So, watch. I'll do it, and you do the next one. As somebody that's not watching, just charity, watch me for a minute. Watch me do this problem. Everybody, don't make me call you out. Look up at the board, unless you're taking a test. Could you poke Lux for me? Oh, there we go. Okay, watch just for a minute. All right. This needs to be put away here. That 4 can go to the exponent, and I'll tell you why in a minute, but just trust me for now that can go there. Again, I'll show you why in a minute. I think of it as putting it away. And then these 2 logs are both base 3, so I can condense them to one log base 3. And then all that's left is what to do with these 2 things. And you times them. It's that easy. 5 squared is 25. And then this, x to the 4th. Do you get, I made one log out of it. That is called condensing. It used to be 2 logs, now it's 1. I'll explain more about why this works and why you want to do it that way. But here's the little side note. What if I start with one that's all condensed, log base 3 of x to the 3rd y, and I want to expand it? Well, then I make 2 logs out of it. Log. And what base do you think they will be?
3.
Base 3. And then I just have to split this up. X to the 3rd here and a y there. You see how I'm making it into 2 logs? This got broke into 2 parts. And then what's missing in between the 2 things? Plus. That is called expanding. Do you get how it's bigger than it used to be? It expanded. All right. Now, this one isn't expanded all the way, though. Can you catch what I didn't do yet that I did on the other one? Ooh, you noticed.
The 3 goes from the exponent to the front.
Yes, this goes down to the front. This one doesn't have it. I mean, it has a 1, but putting a 1 in front is kind of dumb, so you really don't have to do anything on that one. That is a really common oops. I didn't expand it all the way. This is wider than it would have been before. It's the difference between a normal script and a subscript, but that's considered expanded all the way. All right, there's the overall big picture. You have logs that are kind of big and you shrink them, or you have small logs and you stretch them out to be big problems. So go to this slide with me. And this looks so complicated. I'm a math teacher, and I look at this, and my eyes kind of glaze over like, what are they even trying to say? So if you're trying to read something this dense, when they tell you that these can be real numbers, put a number there. So just don't put a 1 in the base. So everybody, please write a 3 right here. We're going to call this base 3. And then it's going to feel a little more normal. And R and S, those can be numbers. So let's make it let's say R is 5. So I'm going to put a 5 right here. And R is 5. And let's say S is I don't know, 8. It'll be easy to forge it right on top of it. This is how I read variables when they tell me that they can be numbers. I put in numbers. Now do you get that log base 3 of 5 plus log base 3 of 8 would be log base 3 of 5 times 8? That's what it's saying. I started with this one when I did it, and I made it shrink to be that. Or you could start with the small one and make it the big one and make it expand. So that's the two kinds of problems we give you today. Either you condense them down to be smaller, or you expand them to be bigger. This one has a minus and you use divide. So remember, they aren't all add problems. If they make it a minus problem, then you're going to divide the two arguments. Here's an argument, here's an argument. Here's those two arguments, they get divided. So subtract goes with divide. And this is that little rule I used and I want to show you a little more of. That C could be in front. Do you get that this is identical to this? It's just they put the C in the front, or it can be as the power. And I want to explain that a little more. Everybody write this one down. Log base 5 of 5. Would you agree that that's just equal to 1? Do you remember this from the test you just had? That would just be 1, right? So if I times it by, let's say, 2 in the front, now since this is all equal to 1, now the whole thing's equal to 2, right? Do you get, if I wanted to, I could have put the 2 here, and I also would have known that with the 2 here, the answer is 2. Do you remember that deal where if the bases are the same, the answer is already as the exponent? So it's still 2. Do you get it doesn't matter if I put it here or if I put it there? The answer's 2 either way. See what I mean? And the same thing would happen if this was a 3. If the 3 is there, it's 3 times whatever this is. And if I want, I could put the 3 there. So again, it's a place you can move the number in front, which is called a coefficient, into an exponent on the argument. Everybody go to this slide. This is your first problem. And if I taught you well enough, you should be able to move these guys to where they should go and condense it to one log with base. Wait a minute, there is no base. So what's the base in this case? Normally it would be, but this one's a ln, so therefore e. Make it one log with a base of e. Try it. I don't expect you to be a master yet. I've been teaching for literally 3 minutes. But I bet you could start. Hudson, what's the log base? Log base e. Then if I want to put them together, you got to put these away first. Were you catching how I did that, Sabins? Where does the 4 go?
To the exponent place.
To the exponent place, yes. And the 2, same thing. I put them away. Now I can get it down to just one log. So what do you think it is? Log base e of, well, I know I got to use an x to the 4th. The only question is whether I multiply them or divide them. Since this is an add, I am going to multiply them. Done. Who had that before I said it? Cool. You know how to condense a basic log. Get how it's smaller than it used to be? It's 1 log instead of 2. All right. And I'm going to tell you something for this next test that'll come in handy. Just like I always say, if you can factor it, you should. Right? I've got a poster for it even. I use it so often. If you can condense it, you should. If you got 2 logs in your middle of solving a problem, condense them. Then you only have 1 log. And your life will get easier if you do it right. Condense it if you can. All right, so here's another one. And you might be like, well, I don't know what to do when there's a 3rd thing. Well, ignore it then. Wait. Act like it's not there. And we'll do it later, once we're done with the first part. So we're going to start here. Liam, they're going to be 1 log. What's the base of that log?
The base is 2
Good. So log base 2 of?
of x.
And then add them or multiply them? Sorry, multiply them, add them, or divide them? What do I do with the x and the y?
You multiply.
You are correct. And now I've got the bandwidth to deal with that last thing. What the heck am I gonna do with that? Belial, I think you would know what to do. Now, I can divide the whole thing, no, just the argument part by z. That's a z. I always put a slash through my letter z's so they don't look like 2's. And there it is. Yeah, you just have to put in a little divide by because they got a minus here. Here's my final answer. They'll always get down to 1 log unless they have different bases, and then you got to go, mercy, I can't do it. They don't have the same base, I can't do it. All right, to this slide. All they do is get a little more complicated, and all you do is 1 step at a time. 1 step at a time. Don't let yourself go cross-eyed with how long and complicated this looks. Just do 1 thing at a time. Liam, do you know what to do with the 3?
You, put it to the X.
Yep. Right there. Is there any others that I could do like that? Sabins, do you see the other one? Or 2?
For the next, like, the.
Yep. Well, this one doesn't have one, but how about this one?
7 and 7 for those 2.
All right. So they all have base 7, so that's good. All of them have base 7. What I'm talking about, is there any other powers that we could move to, you know, like the numbers in the front, we could move up and make it be a power on the argument?
Yeah.
So let's do it with this 4 here. Does your gut feeling tell you you should move the negative away with the 4, or do you think we should just put the 4 up there?
Just the 4.
You are correct. Your gut was right. Just the 4 goes up there. And just the 6 goes up here. 1 thing at a time. If you can do that in math, even when the problem is really hard, just do 1 part, 1 thing. Make it a little easier. Then go look at it again. 1 thing at a time. Okay, I did all of those kind. Now I'm going to go back and see if there's anything else I could do. Well, this is all about getting it down to be 1 log, so let's just do that and get it down to 1 log. Don't try to do it all at once, just do 1 part. Marit, these both have base what?
7.
So then I'm going to make it log base 7. And what do you think I should do with this and this? Well, it depends on what you meant by that. I think you mean this, which is what you should do, and I would say combine them in the argument. Okay. Good. We're good so far. Do you get what happened there? All that happened really was that this part right here and this part right here combined together into the argument part right there. 1 thing at a time. Okay. Then I'm going to have to reveal this next part and go, okay, I guess I got to deal with this now. Now it's got a minus. Do you get that means we're going to divide? We're going to divide this by what? X to the 4th. That's the argument part. Cool. Now we're done with that part. Now this next part, you might think, oh, but now you're going to have to divide it again. And actually, you're right, but there's a shortcut. I can divide this by y to the 6th, but did you know then you're going to have to do a fraction over a fraction and do the flip and multiply thing? So let me just show you. If I put this over 1, which is always legal, then I can go up and flip this over and put it as 1 over y to the 6th. Do you get it? Would have been quicker to just put it on the bottom in the first place. Do you get what I mean? We had to, because there was a minus, we had to divide by y to the 6th. And that was this. Divide by y to the 6th. But then I'm just going to flip and multiply it back. I may as well just put it on the bottom in the first place. There is your final answer. How do I know if it's done? Oh, wait. I forgot something. Condense. Is it condensed to 1 log? Yes. and simplify. I forgot that last hour and a kid had to remind me. Mr. Server, can't some of those X cancel? Yes, those X's can cancel. Why don't you see if you can be better than Mr. Server was last hour and get the final answer. Simplified. This is right off the top 20. You know that it's there? Because of moments like this, we've already practiced it several times. If I hadn't done that top 20, a lot of you wouldn't know how to simplify this. But I think because we talked about it enough times on the top 20, I think you're going to know that this simplifies down to the x to the third is like xxx, and this is like xxxx, and most of them cancel, but there's one x left on the bottom. Put it on my keyboard. And then I got a y here, and I got y to the sixth there, and only one of the y's will cancel, so then I have y to the fifth left on the bottom. When there's a divide like this and there's nothing on the top, what's really on the top? A 1. Because when you canceled those things, technically there was a 1 in each spot. When you canceled this and some of those, there was a 1 left. You're technically reducing it to 1. So there is your final answer. Because a bunch of stuff canceled in the arguments. That is the part that a ton of kids are going to get wrong on the test. They'll get it condensed to 1 log because you know you're not done unless you got 1 log. You'll get it to 1 log, but will you simplify it enough? That's the question. All right. Without my help, can you put things away and condense it to 1 log? But it doesn't have a base. Well, then you should know what the base is. Okay, so I've given you some time to try this one. I hope you put this 2 away right there, and then it's not here anymore. And I hope you put this half away up here. And I know you don't like fraction exponents, at least some of you. That's probably why the last test had a lot of C's. Not tons, but more than normal. Because things like that, you're not sure exactly what it means. It means square root of. That means the square root of y. So then if I put them together as 1 log, it'd be log. You don't have to write a base, but in my opinion, you should. You don't have to. It just helps on the simplified part. And then I've got x squared, clearly. And I've got a y to the 1/2, which means square root of y. And I'm dividing them because that's to subtract. Now, I know some of you are going to ask me, can I use a 1/2 power? Yes. You would have been allowed to leave that as y to the 1/2. It's allowed. I just want you to see a lot of times your test questions will be written like this, where the square root symbol is there instead of the 1/2 power, because they mean the same thing. Do you get I got it down to 1 log? I condensed it then. Now, is there anything on this one that I can simplify? No, because the x's and the y's are completely different variables. They won't like cancel. If that would have been an x, you would have totally had to deal with the getting it together into simplifying the x's on the top and the bottom. But it wasn't, so you didn't have to. All right, moving on to this page. Now, you're going to condense these two, and you're going to think this is actually pretty easy. They have base 10, so I'm going to put a base 10. And then he said that when there's a minus here, there's a minus there, that it's divide. So I'm going to divide my 2 arguments, and then the x squared minus 4 will be on top. Trust me, you would have all got to here, but then some of you would have been smarter than others about the ending. Do you get how the minus meant we had to divide them, and the 1 is divided by the other? Does anybody know what I'm talking about being smarter than the others on how to finish this thing? Don't say it. One person thinks they know. Anybody else think they know what's up? 2 people? 3 people think they know? Maybe 4? Brady, what's your gut? Factor it. There was a lot of people not raising their hand because that's why I made this. Actually, I didn't make it. That's why I say all the time, and some kid made it for me. If you can factor it, you should. That can be factored. So it factors. So take a second, factor it. You'll go, oh, I see. It can be simplified. Deal, what does that factor to?
X plus 2, x minus 2.
Yup. And then, what happens next?
Minus x minus 2 is canceled.
Doop doop. So then your final answer is log. You don't have to write the base, but I like to. And then x plus 2 here. And I'm done. I condensed it to one log and I simplified it. So many people got burned on this last test because of powers. And look at that, there's powers again. This has an x squared in it, which needed to be factored and instead canceled. All right, this one. They look scary, I know. But just do one thing. Just do that. There's something you can do on that one to put things away. Then condense these two. When you're done with that, put in this last part, and then see if you can simplify it. Tons of kids, condense it to one log, and then don't simplify it. I'll pause for a sec while you give this one a try. Give it a shot. Where does that 2 go?
3.
Yep. And then it's 3 to the second, and then you can just do that. What's that equal to? All right, so now I got log base 6 of 9 plus log base 6 of 4. And I don't want to try to do too much, so I'm just going to stop there. Tell me how to put these two together, Noah.
Log base 6 to 13.
Close. You got to multiply the 9 and the 4, not add them. 9 times 4 is 36. Get how you multiply them?
Yeah.
Okay. Then I got to subtract this part. Jaden, tell me what to do. Ah, that's interesting. She's right, but others of you are going to do it differently. Would you agree that log base 6 of 6 is 1? Which is not wrong, but then it's going to be hard to combine them. But isn't this really just like 6 squared? So therefore, this whole thing is really just 2. 2 minus 1. So the final answer is 1. Now, I know some of you will be like, but I thought you had to combine them together. And if you had done that, your log base 6 and your log base 6 would have had log base 6 of 36 over 6. And newsflash, that comes out to log base 6 of 6, which is 1. Either way, it's 1. Who all got to a final answer of 1? All right. That's not that many of you, and I get why. It was complicated at the end. Things like this, you got to be able to realize, oh, wait, that's just 2. And that's just 1. And 2 minus 1 is 1. If you put it all together into one log, it would have worked. You would have just had to simplify this to 6. And log base 6 of 6 is 1. Okay, this slide, please. We have made it to expand. It's almost like Jeopardy. They gave you the answer, and they're asking, like, what would the question have been? If the answer is this, what was the question? Well, it would have been 2 logs. What are their bases? Well, they don't have a base. So then I guess you don't have to put a base. But I think it's smart. My best advice is if it doesn't have a base, put a base of 10. Then, because it's a times in there, I know what to do between them. Hamburg, do you know what to do between them? Nope. When it's... No, you're right. You're right. I think I had it wrong in my head. Yes, you add. Very good. I thought I was asking you this question. They are multiplied right now, so therefore, you add. Good. Okay. Is there anything else I have to do? Expand, check, and simplify. Well, there's supposed to be a 10 here, which can be simplified. And there's supposed to be an x here, which can't be simplified. So then what do you think the final answer comes out to, Turf?
Log base 10 1.
Well, this is just 1. You don't say log base 10 of 1. It's just 1 plus...
Plus log base 10 of
There you go. This is 1, isn't it? Log base 10 of 10? It's just 1. All right. When they talk about the power rule, they're just saying that this could be in front. See? That's what they mean by the power rule. The quotient rule means if you're dividing them, it's going to be a subtract. And the product rule means if you're multiplying them, it must have been an add. Okay. I think this is going to be the last one that we do together, and then you got a worksheet that's like this to practice it. The practice is key. I think you've realized by now that if you practice, you'll do better. So, I give you the advice to just do one thing at a time. And this is so complicated, I would just look at the top and I would think, well, what if I just had to do that? Well, it says expand. That makes me think I should write 2 logs. And that's true. If I'm just doing this, just doing the top, Brady, is this an adding in here or a subtracting in there? Add. And then I just put these 2 in here. I know some of you are thinking, aren't you going to break that up? Yet later. I'm going to simplify it later. And then the x squared part, that goes here. There, I did the top part, and I was avoiding the bottom part because I knew it would make it complicated, and it will. But now we got to deal with it. This part is being divided, and therefore subtract. Another log. What's the base? It doesn't say a base. Must be base 10. My advice, write in a base 10 on all the bases that aren't there. And then this 3y to the third goes here. Now the scary part is, after all that work, I am not even close to done. Because there's a bunch of simplifying you can do. Some of these just turn into numbers like 3. Some of these can't be simplified. Some of them, you have to use the power rule to move the argument's power out to the front. And some of them, like this guy, still can be expanded into 2 logs. Give this a try. I'm going to pause for a second. While you expand it further, like that last one can be 2 logs, and simplify it. Some of these can just be numbers. Like it'll simplify down to 6. I'll pause. All right. Now I said it was expand and simplify. And this part can be simplified because you had problems just like this on your test. This 1,000 needed to be thought of as 10 to the third. If you think of it as 10 to the third, you'll realize, the bases are the same. So that's just 3. Plus, this one needed to have the 2 go down in front. Very common to forget that. And then this one has to be expanded because it's got 2 things in the argument. So you make 2 logs out of it. Now, I know you're going to wonder what to do with the signs. So think about this for a second. Should I just pick one of them and make it negative, or do you feel like both of them should be negative? Like there's a minus in the front. Should I just pick one of them to be negative, or do you think they should both be made negative? Nope, both of them should be made negative. I get that that's confusing, but this negative here tells you that both parts of this log need to be subtracted from the original. All right, so that minus there needs to be broken up into 2. And then this 3 goes here. This y to the third goes here. And I know you're new at this, so I totally would get that you might not understand how this negative would work. If you had just had one negative in the front and put a parenthesis around this, do you get that then I'd need this to be positive so that the negative could distribute to both of them? If you wanted to do it with a parenthesis and a plus, that would have been okay. But I'm going to distribute the negative to both of them, so they'll both be a negative, like this. Okay. Now you keep on doing it. You keep on looking back and saying, is there anything else I could do to make this like simpler? Like 3, it can't be any simpler than that. Can I simplify that one? Really, it's about this argument here, and I can't break the argument up anymore, so it's as simple as it gets. Log base 10 of 3, that's as simple as it gets. You can't break the 3 into anything else. But that one right there, did anybody catch that 3, the y to the 3rd, should be in front? Did anybody catch it? 4 people, good job. That 3 should be in front here. I know. Only 3 kids in the whole room caught that. So that's the kind of thing that's going to cost you on the test. Because they said expand, and that's not expanded all the way unless you put the 3 in the front. I even argued, I argued with myself, like, shouldn't a 3 here be just the same as a 3 there? But in every instance, when asked to expand, the key every single time, and the internet, will tell you that that has to be here to be expanded. Okay. Now, tonight's homework, I don't expect you to be perfect yet. It's the first day of the unit, but we're doing the odds. So everybody pull it up, and would you read me number 1 of tonight's odds? You'll probably finish in class while I'm handing the tests back. Pull up the homework, please. Dominic, would you read me number 1? You got this?
Yeah.
Okay.
Log 3 plus log 5.
Say base.
Log 3 plus log base 5.
Plus log base 5. Is there anything else? There must be something in the arguments.
No.
Huggins common log.
Oh, there isn't a base.
Yeah.
Okay, so then if there isn't a base, could you please say a base of 10? Try it again.
Log base 10, 3
Yep.
plus log base 10, 5.
All right. Now, you were actually saying it okay. It's just I thought they must have been base 3 and base 5, but they're base 10. Okay, cool. Since they do have the same base, you can condense them into just one log, and that's the whole point. So now it's one log. Log of what? Well, base 10 again. I say put base 10 in. That's how I say. And that'll force you to realize the 3 and the 5 are the only things left that you can do anything with. And then you either have to multiply them or subtract them. No, wait, or divide them. I guess that's the only 3 logical things you could do with them. And the actual answer is to multiply them. So 3 times 5 is 15, and that would be okay. If you said 3 times 5 in here, then you'd have to go, but can I simplify 3 times 5? Because you'd always condense and simplify. So log base 10 of 15. I think that's it. Did anybody else get that? Okay, good. All right. Odds. If you get stuck, it's totally natural to be like, I'm not sure I'm doing this right. It's okay to check the key. That's legal. Check with the kid next to you. That's all I have for you for today.